This meeting is being recorded.
Section 2.4 discusses when carbon atoms have formal charges. So this term, formal charge, refers to when carbon does not have four bonds. Remember, we discussed carbon is tetravalent, and that makes a nice, happy, neutral carbon when it has four bonds. So we see sometimes carbon will not have four bonds, but it will either be, missing a bond or it will have a lone pair. So what we call a carbon with a positive charge is a carbocation. So from carbon and an ion that's positive is a cation. So we have carbocations. So down here, we see what that would look like if we drew the bond line structure of this structure here. We see this central carbon atom in the middle has a positive formal charge. So this is how we would draw a carbocation. We have another example here. So this would be a carbon that has bonds to three carbons and then one hydrogen is missing. So no hydrogen atoms here at all. This next carbon, we expect to have two hydrogens on a neutral carbon here because there's two other bonds to other carbons. So again, this is a abbreviated C+ carbocation that's missing one hydrogen atom. And then what we have here is there's only two hydrogen atoms on this last carbon, so we're missing one hydrogen again at this carbocationic site here. So these are three different examples of carbocations, and they all exhibit only three bonds, and then they'll have an empty orbital. Right? That would be, lacking a bond, we're going to have an empty orbital. So we'll think about this when we talk about shape, molecular shape that results. Then we have down here a carbanion. So this is when a carbon exhibits a negative charge. So in this case, we see a carbon having three bonds, and then where it would normally have two electrons shared in a covalent bond, in the fourth spot, it has a lone pair. So if we did a formal charge calculation, right, we know formal charge equals the number of expected, right, valence electrons, so the number of expected electrons involved in bonds. In this case is 4 for carbon, it's in group 4. And then we subtract the number of, we'll say, lines, aka half of the bonding electrons. So we can just count the lines. So we have 1, 2, 3, plus the number of lone pair electrons, and we can call those dots. So we add lines plus 2 dots, and we get 4 minus 5, for a formal charge of -1, right? So this carbon has that negative charge, and if we were unsure, if it wasn't indicated for whatever reason, we would calculate it using this formula for formal charge. So you can do this with any atom. So sometimes they may not be indicated, like on this molecule here, and you're asked to draw them. So they ask us in this specific structure to draw any formal charges. So what we can do is we can use a shortcut. So every hydrogen should have one bond to be neutral. Every oxygen should have two bonds and two lone pairs to have a full octet and be neutral. We'll see every nitrogen would have 3 bonding pairs and 1 lone pair to be neutral, right? And like so. So we'll do that for all of these atoms here. So this oxygen, what do we see? We see 3 bonds and 1 lone pair. So this would have a +1 formal charge. Every carbon appears to have 4 bonds, right? We have to assume hydrogens here. So this would be neutral, neutral. This carbon has 4 bonds. This hydrogen has 1 bond, that's neutral. This oxygen 2 bonds and 2 lone pairs, so that one's neutral. This oxygen over here has 1 bond and 3 lone pairs, so this we would calculate would have a -1 formal charge. Let's see, this nitrogen looks neutral, 3 bonding pairs, 1 lone pair, so we can eliminate that. This carbon would have a hydrogen, so this is neutral. This nitrogen here has 4 bonding pairs, so this would be a +1. When you have more electrons and less bonds, you get a negative charge. When you have more bonds and less electrons than expected, you get a positive charge. So that is a quick way to go through a molecule and figure out the formal charge without doing the full calculation. So that's where we'll end for this lecture, and we'll continue with section 2.5 next time.